If you're not familiar with Cisco Talos, it is Cisco Security's threat intelligence organization, and it consists of somewhere between 250 and 300 full-time security experts, threat researchers, and data scientists whose full-time job is to build security intelligence into Cisco's portfolio of security features. And they have a lot of data to work with here too, because they have access to the full breadth of threat information that any Cisco security device out in the wild is collecting. So when a Cisco security device, or also a Cisco security software product, detects a new yet unrecognized threat, it sends that information to Talos, and in turn, Talos pushes updates to all other Cisco security devices and products, effectively making that new threat a well-known threat across the Cisco security portfolio. This intelligence benefits every Cisco security product, including the MX. And the MX is using specifically Snort IPS, and you can integrate with ICE. We're certainly using Cisco AMP. And across this whole portfolio, Talos blocks about 20 billion threats every day across the world. So that's the value of having Talos. And there's been some pretty notable threats over the years that Talos has identified and then ultimately pushed out very timely definition updates for. I'm sure you recognize some of these threats here. VPN filter, I think, was the most notable, most recent threat. But I'm sure we all remember WannaCry back from 2017. I think that's the most notable threat out of all of these. WannaCry was basically ransomware that affected Windows machines, and the damages of that ransomware ranged from hundreds of million dollars up to billions of dollars. But Meraki MX customers that had IPS enabled and that had the security rule set turned on, they were protected against that before most people even knew what it was. So that's an example of the type of intelligence that Talos is building in to this feature set, to Cisco's portfolio of security products. So the point is, the MX provides powerful dynamic security, and that's possible because it's backed by Cisco Talos. So this is a huge selling point, and you really should be using that whenever you're positioning MX as a security appliance. I'm logged into Meraki Launchpad, and there's a really great demo built in here for Security Center. We have plenty of threats staged that you can show off. So to get to the Security Center, you can certainly access it on a per network basis. So I could go to Security and SD-WAN Security Center. But I think even more powerful is to show the organization-wide Security Center. So this is going to show you security threats affecting every location within your organization. So if I click on Security Center, it's going to take me to the organization-wide view, where now I can see events over time, the number of events and the date at which they occurred, and then the networks that were affected, for example. I can see that Wednesday I had 33 threats across my whole organization, and it looks like my San Francisco network is the most affected network. If I scroll down, I can see the clients on the network that are affected. I can see the countries where these threats are originating from. For example, it looks like quite a few of them are coming from Germany for whatever reason. I do have some threats sourcing from the United States. I can see the most prevalent threats, and then things like the most affected operating systems. So this is what you get from just the summary page. And you can filter this page if you want to. You can search for certain things. You can filter based on these criteria here. But then if you go to the MX Events tab, this is where you get to see the individual specific events. Now here you can go ahead and block certain things, or you can see what was blocked. You can see what was allowed through, depending on how you had your security policy set up. You can get more information about these threats too. So if I see that the source here was malware.ycar.org, I can click on that, and then I can see more information about this. If I see the specific client that was affected, for example here, I can click on that client, and maybe because of the policy or the rule set I had turned on, maybe that threat was allowed through. If that threat was allowed through because of the way I had my rule set turned on, maybe I want to click on this client, go to the details page, and go ahead and block it on the network until I'm able to remediate that threat. I can do that. So I can come over here to device policy, I can block this, hit save, and then I can come back to it once I'm able to actually remediate that threat on the physical device. The power here is that this is a unified security center showing you all of the events here that have occurred because of something that advanced malware protection has blocked, or the Cisco Snort IPS, or even Cisco Umbrella events are going to show up in here too. But the power here is that you have a unified experience when it comes to browsing the threats that are affecting your entire organization. Site-to-site VPN is extremely easy to stand up with Meraki, and for that reason, we call it Auto VPN. It's fully cloud orchestrated, and I'm going to walk you through the process to show you what exactly that means. Once you enable VPN and dashboard, it's a 3-step process to stand up an IPsec VPN tunnel between sites. So as soon as you turn it on, the appliances are going to reach out to the cloud registry, which is a server that we host within Dashboard. They're going to register their WAN IPs, the port numbers that they're using, and then also the VPN subnets that they want to advertise. And then that cloud registry server is then going to propagate that information to every other participating MX. It doesn't just have to be 2 MXs, it can be tens or even hundreds of MXs. And then all of those other MX appliances are going to know how to reach each other at that point. And then once they have that contact info, the peers negotiate and establish that AES encrypted IPsec VPN tunnel. And that's all there is to it. And that is, again, why we call it Auto VPN. So it's extremely easy to configure. You can have a full mesh VPN deployment configured with this if you want to, or you could just have a hub and spoke VPN topology, but it will be built in seconds using this process. And because of that cloud orchestration piece, these appliances can form VPN tunnels through upstream firewalls if you have them, or multiple NATs possibly could be upstream using a UDP hole punching process. It's also self-healing because that whole process executes every time there's a change on the WAN. So if the appliance gets a new IP because it's using DHCP, or if that port number changes, that tunnel is going to come back up. So actually, you could say goodbye to having static IPs across all of your locations. You don't need them anymore for this. So across the board, all of the security-related feature sets are incredibly easy to manage. For this demo, I'm actually logged into Meraki San Francisco. This is our headquarters network. So we have a huge number of clients passing traffic here. It's a great network to demo. But you can see that right now I'm looking at our client details page. This is the network-wide clients page, and I can see every client device that has been seen by any Meraki device in the network, including security appliances. So if all I had was a security appliance, I'm still going to get all of this visibility. But when you add other Meraki devices, that visibility is aggregated into this page as well. So I have a table view of all of the clients in my network. I can see the name of the client, I can see how much traffic they've passed, the IP address that they might have, and I can add and remove columns from this list. So maybe I don't care about OS, but I would like to see MAC address. I can add that in if I want to. And then as I hover over these clients, it's going to highlight their usage in that aggregate usage graph there at the top of the page. Now, if I want more visibility into the types of traffic, I can actually hover over this pie chart and see the types of traffic in use. So we get pretty granular there. You can break it out into a list view too by clicking more. And we'll show you more specifically what types of traffic are in use. For example, you can see Meraki HTTPS is at one of our highest traffic types. We've got lots of UDP on the network, lots of file sharing apparently. And this list is pretty long. We do recognize quite a few applications. YouTube and Netflix never fail to show up in this list. Maybe someone on your network is abusing their bandwidth by streaming video streaming sites during work, like Netflix, for example. If that's the case, you can identify that traffic here, and you can click on a traffic type and see who is contributing to it. So in this case, I can see who is actually watching Netflix. So if I click on Netflix, I'm going to see the clients that are contributing to this rule. I can see that this client has contributed almost more than a gigabyte of Netflix usage for the last day. So 22% of the aggregate Netflix usage today is due to this client device. So if I'm not okay with that, if I want to limit that traffic, I can click on this client device And that's going to take me to this client's status page where I can then take action on that. Let's assume that one of these other clients is my bandwidth abuser for Netflix. Let's say that this client here is my device that is streaming too much Netflix. If I click on it, I have lots of information about this device specifically, including the username, given that we're using 802.1x here. I can see the location of the device because we do have our access points placed on the map here. But if I scroll down, I also have a policy section where I can then apply a specific policy to this device. So if I want to block it entirely, I can certainly do that. I can put in a message that says, stop watching Netflix. And then they're going to see that when they're redirected to a splash page. Or what I can do instead is apply a group policy and limit Netflix for this specific user or this specific device. And we already predefined a policy that's probably going to do what I want, so I'd choose that, click save, and now I've effectively limited Netflix just for this one device. This is just one example of how we give you visibility into the types of traffic that are in use on the network and who is using them, and then we give you the tools that you need to actually act on that data. All MX appliances do support dual wired uplinks with an optional cellular backup. Some of these appliances have a dedicated secondary WAN port, others do not. So for those that do not have that dedicated WAN, you do have the ability to reconfigure a LAN port to be that secondary WAN port. And you can plug whatever you want into that WAN port, as long as it's Ethernet and it has internet connectivity upstream. So if you're using MPLS, for example, that's fine, as long as that circuit has an internet breakout somewhere. And we are working on making it so that you don't necessarily need that. That is in beta, so you can use MPLS without an internet breakout, for example. But right now, you do need an internet breakout for every internet uplink. That secondary WAN is going to be used for failover out of the box. That is the default behavior. Our appliances also support HA with VRRP if you need added hardware redundancy. And you can also configure load balancing across those dual WAN uplinks. You can even create more granular flow preferences for specific traffic flows if you want to. Why are customers moving away from MPLS in the first place? Well, one reason is that the volume of business traffic has increased substantially, and it's projected to continue to increase. And this is partially due to the rise in utilization of applications like VoIP, video conferencing solutions, and other on-prem applications that are being used between sites. But in addition to that, we're also seeing customers migrate toward SaaS applications. And companies are estimating that 80% of their business apps are going to be SaaS fully by 2023. And as apps move to the cloud, that means that more business critical traffic is bound for the internet. And what do we know about the internet? It's prone to packet loss, things like latency spikes. It's extremely unreliable. To address this, we could keep that traffic on the private WAN, right? That's our first option, but that is prohibitively expensive. It has serious cost implications. The second option is to augment that MPLS connection with VPN over broadband, which you can do with Meraki. And then thirdly, and the most cost-effective solution is going to be to have two different broadband links and utilize SD-WAN to choose the best link at the moment. And the reason that works is because chances are you're not going to have the same problem on both WAN links at the same time. So SD-WAN is going to allow you to avoid those issues by changing connections for your traffic flows and choosing the best connection at the time. How does Meraki do SD-WAN? Well, there's a few primary components or mechanisms behind SD-WAN. The first is dual active VPN. So first, we need VPN tunnels that are actually interconnecting our sites, and AutoVPN has us covered there. Secondly, we need policy-based routing. Policy-based routing is going to allow us to configure static policies that define which path certain traffic flows should take, and then when that traffic should fail over to that secondary WAN. And then thirdly, dynamic path selection. And this is going to allow us to create custom performance classes that we can insert into those policies that I just mentioned, so that rather than using static definitions, DMX can adapt to changes like packet loss, latency, and jitter, and then choose the best uplink for us. These things are not necessarily unique to Meraki SD-WAN. But what are these things. First of all, it's going to be how you manage our SD-WAN. You're going to be able to manage your entire organization-wide SD-WAN deployment behind a single pane of glass. The visibility piece, we're going to give you visibility into VPN performance, WAN link statistics, traffic flow visibility, all out of the box, no setup required. And if you want to scale your deployment, all you have to do is add more appliances to dashboard. And when it comes to rolling out new locations, you're going to be able to do that very quickly with zero-touch deployment if you want to. Let's take a look at SD-WAN in action. What I'm going to do now is configure SD-WAN on the new branch office that we just stood up in that first lesson. So remember when we did that zero-touch demo, we created this new Chicago office from scratch. I'm going to demo SD-WAN here on this same network. But remember, the foundation for SD-WAN is AutoVPN. So we're going to start there and make sure that our VPN topology is configured properly. So I'm going to duplicate my tab here, and I want to pull up my San Francisco network. San Francisco is our HQ in this situation, and it is going to be our VPN hub. So if I go to my Security and SD-WAN site-to-site VPN page, I will see that it is in hub mode, and I have a few different local networks, a few VLANs. I'm going to advertise all of these in the VPN. And that means that my remote peer is going to have a route pointing back to these subnets. So that looks good. And then my Chicago branch is going to be a spoke in my VPN. So if I pull up the site-to-site VPN page in Chicago, I should see that it is a spoke. It is pointing at my San Francisco as a hub, and I am going to do a default route for this network. So that means all my traffic is going to go there, and I need to make sure that my local networks are advertised. That looks good. And actually, if I want my guest traffic to break out to the internet connection directly here, I could turn this off. Make sure the other ones are on. So that looks good. So now I have my AutoVPN topology set up, and it's ready to test SD-WAN. So I'm going to go back to my appliance status page here in Chicago. And you'll notice that now I'm looking at information specific to this appliance. So I can see that I do have 2 different WAN links. I can see information like the firmware version, the config is up to date. I can see historical connectivity information. But in my opinion, there is really no better way to test SD-WAN than to use a real-time application. Because real-time apps are where your users are really going to feel the effects of issues on the WAN the most. So in this situation, I'm going to use WebEx to test SD-WAN. We're going to use a live call, and we're going to play around with some different scenarios to see how it works. So what I'm doing now is I'm actually going to host a WebEx on my computer. And you can see I've already started up the meeting. And this computer is actually connected up through the internet connection here in the building. So for our purposes, we'll just say that this computer is hosting a meeting somewhere up in the cloud. But I'm going to join this meeting from an iPad that is connected to my Chicago branch Wi-Fi. So the traffic will be flowing through my branch appliance. And if I pull up the settings, you can see that it is indeed connected to my branch access point, to my branch wireless. And if I pull up the WebEx app, you'll see that I've joined that WebEx meeting from my iPad. And to simulate a video conference, I am going to stream a video through WebEx. This video has audio as well, so we'll be able to audibly hear how this meeting is performing, and we'll be able to play around with some various SD-WAN policies. So let me go ahead and hit play. I'll turn up the audio on this call so that you can hear what it sounds like.
Finally, you can move licenses between organizations on your own. You don't have to call support to move licenses between orgs with this new model. So let me show you kind of a case study or an example here.
So you can hear that it is not great. It's breaking up. It's cutting out entirely at times. Quality is certainly not ideal, and if this happened in a real-world scenario, I can bet you that your customer is definitely going to be letting you know, right? Or the IT department's definitely going to be aware that the users are having call quality issues. So let's take a look at why that might be. First of all, in my Chicago appliance, I can pull up the uplink tab, and I can see stats on my WAN uplink here. So if I want to change this to the last couple hours for some more granular data, I can look at my latency and packet loss counters. So I can see that WAN 2 has about 180 milliseconds of latency versus 3 on WAN 1, and upwards of 50% packet loss on WAN 2 versus an average of 0 on WAN 1. So I'll bet you that this WebEx traffic is probably flowing over my degraded WAN 2, and that's probably why it's sounding poorly. But I'm just hypothesizing at this point. If I want to know for sure what the issue is, or if that traffic is actually going over WAN 2, I could pull up my VPN status page. And I mentioned this earlier in the presentation. This is where you're going to see information about your auto VPN tunnels, like the up-down status, the average latency over the tunnel, your traffic usage, connectivity historically. But we're also going to show you flow preferences or your uplink decisions and where your traffic flows are actually going. If I filter for the IP of my iPad, which is going to be 10.1.4.4, I can see that yes, the majority of these traffic flows are actually going over WAN 2 right now. And that is probably my issue. But if I click on WAN 2, it's going to give me more granular data. It's going to give me that packet loss and latency data over the VPN, inside the VPN tunnels. So you can see here that my uplink 2, yeah, I've got around 180 milliseconds of latency. I've got quite a bit of jitter, definitely lots of packet loss. We also give you a MOS score, which is 1 on WAN 2. If you're not familiar with MOS, Cisco recommends that it be at least 3.5 or higher. Otherwise, you will audibly be able to notice that there's a problem with the call. But uplink 1, I assume, looks pretty good, and it does. Much better. Our MOS score is 4.1, so it's certainly the better link for voice right now. So how do we fix this? Well, SD-WAN allows us to configure policies that are dynamic, that allow the MX to choose the best link for the application. So to configure these with Meraki, you would go to Security and SD-WAN, SD-WAN and Traffic Shaping, and you'll see WAN 1 is my primary. That's the out-of-the-box default. But if I scroll down to my SD-WAN section, you can see we already have an SD-WAN policy that is saying we want to send WebEx traffic out WAN 2, but fail over if that link goes down, which is a fine policy, right? There's a lot of different reasons why a customer might have a policy configured like this. So if the link physically fails, it's going to fail that flow over. But what it's not going to do is adapt to problems like we're having right now. What happens if that internet provider suddenly starts having 50% packet loss like we are right now? You're going to hear the effects of that call. Same thing would happen if we didn't have a policy in here. If that happened to our primary uplink, you would experience the same issues. What I can do to improve this is click on the policy, and I'll show you how we came up with this traffic filter. If you click on this, you have a lot of options. You can define it manually if you want to, by protocol, source and destination IP, source and destination port if you want to. But we have lots of layer 7 predefined definitions here, such as WebEx under VoIP and video conferencing. And this is going to use primarily host names to identify these. Some of these are going to use other things like port numbers, like SIP, for example. It'll look at some protocol headers too. But WebEx is doing the trick for us, so we'll keep WebEx. And then you can see the preferred uplink is WAN 2, fail over if the uplink goes down. We don't want that. We would prefer that it fail over if there's poor performance. But poor performance based on what? Well, you actually can define your threshold for that. So I can do that by creating a custom performance class. So I'll create a new one here, and I'll just call it WebEx. And let's say no more than 150 milliseconds of latency, no more than 30 milliseconds jitter, and we'll say 3% packet loss. So we'll save changes there, scroll back down, and now I just need to reference this custom performance class with my policy. So I'll click on my policy, and let's say prefer WAN 2, but fail over if there's poor performance based on WebEx. Click Save. And before I finalize this save here, what I'm going to do is turn the volume back up on this call so we can hear it. And then I'm going to pull back up the VPN status page, and we should be able to both hear and visualize when this policy kicks in, because the call should get much better. Okay, so I'll go ahead and turn it up and click Save.
And how this works for let's say, this fictional customer. Okay, so on January 1st, we'll say this customer decides to order.
Still sounds pretty bad, as you can hear.
Licenses. and 6 days later, they go ahead and claim those into their dashboard org. Haven't assigned them to any device.
I'm going to go ahead and filter my uplink decisions again.
At the end of the month,
still on WAN 2.
Assign 5 of those licenses to devices. Only 5 of them are accounted for, and they're assigned to devices.
And there we go. It says it's on WAN 1. Let's hear how it sounds.
So on February 28th, after 90 days, remaining unused licenses activate.
Sounds quite a bit better. I don't hear it breaking up anymore. I can see that the flows are on WAN 1 now, and that is because of that policy I just put into place. Okay, so this just took care of this problem for us dynamically. As soon as that is resolved by the ISP, I would expect that those flows would be moved back to the WAN that I originally wanted them on, which is WAN 2, and everything should be fine until I need to fail those flows back over again. So that is the power of these custom performance classes and that dynamic path selection. So that's one scenario. But what happens if that link physically fails? Well, I want to demo that as well. So I think what I'll do is I'm going to replace that degraded WAN 2 with a normal quality WAN. So this is going to match the quality of that WAN 1. So I'm swapping that out right now. And since WAN 2 is now going to be considered to be a quality link, I would expect to see in this uplink decisions table this WebEx flow move back over to WAN 2. Now the MX will take some time to test the link and make sure that it's usable, but yeah, there you go. We can see that we're already failing the flows over to WAN 2. Make sure the call sounds okay.
When you apply that license key to the dashboard, it's generating these individual licenses.
Yeah, it sounds pretty good. Okay, so we're back on WAN 2, but what happens if WAN 2 fails? So what I'm going to do is physically pull WAN 2. I'll turn up the call, and we'll make sure that we don't lose this call.
The dashboard, but at the back end, this is what we're doing. We're splitting that license into multiple individual IDs.
Okay. WAN 2 is out. I did hear a small blip. It interrupted for just a split second, but the call did not drop. It's still running, and if this happened to a customer or a user, they're probably not going to report that in that scenario. That was so fast and short, they probably wouldn't notice it. That is the power of SD-WAN. It's going to help you in both of these scenarios, and it's going to take care of itself when these things happen.